can receive this later. Okay, so we now consider a point like this, which is at a distance x from the bottom. So we make a free body diagram of that section. Length x plus the person plus the sling. You can see the tension at that point plus the weight, which is the mass x part of the string plus the person plus the sling. These are the forces and the acceleration is E. So T will become how much? T will become this total mass into G plus E. So that will become x by L times 15 kg plus 150 kg. Was it that or was it, sorry, 8? L was 15. L was 15 and the mass was 8. So x by 15 into 8. Okay. Mass of that section will be m by L into x like that. So mass of the string was 8 kgs into G plus A. So that is 10 plus E. This is the tension. So if you send a pulse upwards, if you send a traveling pulse upwards like this, the instantaneous speed of the pulse becomes square root T by mu. So that is square root of 150 plus 8x by 15 into 10 plus E divided by linear mass density, which was 8 by 15. Like this. So you can divide by 8 by 15. So this will become square root of 80 plus x into 10 plus E. This becomes the instantaneous speed of the pulse, which you can write as dx by dt. Now you integrate both the sides. So you get the time taken for the pulse. In the question, the time taken for the pulse to reach from the bottom to the top is given to us as 0.25 seconds. So from that we can find out E. So next step. Integrate this. So this is going from x equal to 0 to x equal to 15 meters in the time 0 to 0.25 seconds. can square both the sides. Solve for this now. Okay. So from this you should get the value of acceleration. So hope this is clear, Dhruv. Yeah, Dhruv, you're unmuted. Yeah.
Sir, in this, why did you take you only made the free body diagram for the sling?
For the
Sling
tension.
or the whole cable?
No, I
Like
didn't
there
make
were
the
two.
whole cable beta. The FBD, if you can see, is for this portion of the string plus the person plus the sling. मतलब ये point
Okay.
के नीचे combined FBD. That
Achha.
is why you can see the weight is the portion of the string plus the mass of the person plus the mass of the string. That's why this thing here is m by L into x for the string plus 80 kg was which was the person plus 70 kg.
Okay, sir.
Yes,
Yes, sir.
that was it. So this is clear now, Dhruv.
Yes, sir.
So we'll move on to the next question now. Now the next example is something like this. We have a combination of two semi-infinite long wires kept on the z-axis and y-axis, and they carry a constant current as shown in the figure. Calculate integral b dot dl on the line qp. Okay, so let's understand this question. It is going to minus infinity on the y-axis. Current is coming from infinity down the z-axis. This is our x-axis. Now we have these 2 points. E, which is the point E, 0, 0, and Q, which is the point 0, A, 0. We have to find integral B dot dl along the line PQ from Q to P. Okay, so what we have to do over here is Yashraj, to answer your question, you can just send me your question on WhatsApp. Just send me your question on WhatsApp. Okay, so here the thing is, one option is that can we use Ampere's law, but there isn't that kind of symmetry that we can use Ampere's law directly. So what we will do is we will try to look at the magnetic field itself. Okay, so one of the things we can try here, we can do here is we can make use of superposition. So if we find the flux due to this section of the wire, the one which is along the z axis. Okay, so let us say the section of the wire which is along the z axis. Section 1 and this is section 2. So we can calculate the integral B dot dl, the circulation thing, due to section 1. Now due to section 1, you can see that if you look straight into the xy plane, now again you use superposition. If you had a straight current going down the z axis, okay, like this, and then you are doing integral B dot dl along a closed path like this. So you had this, suppose we had this. Okay, if I was an infinite state conductor from z plus infinity to z minus infinity, then your integral D dot dl over QPRS would have been mu naught I. Okay, so your integral B dot dl from only Q to P by symmetry would have been 1/4 of mu naught I. Okay. So therefore, if the current exists only from Z plus infinity to Z equal to 0, then your integral B dot dl, sorry, not circular integral, just integral B dot dl. So integral B dot dl from Q to P will just be half of this further, because of the symmetry. It will become 1/8 of mu naught I. Okay. So you can see the contribution in the first part from section 1 is this much. Okay. So you can use this for the contribution to V dot dl on this part due to this. Okay. Now similarly, if you have to work out the contribution due to this part, which is along the section 2. Now that I think will contribute 0. Okay. So how we will know it will contribute 0 is that at all such points, the direction of magnetic field due to a wire along the y-axis at any point on the xy plane will always be along the z-axis. Okay, so it will contribute 0. So magnetic field at any point on PQ due to section 2 will be along K cap. Okay. Because ideal on that wire is along minus J cap. Okay. And R is xi cap plus yj cap. So I dl cross R has to be perpendicular to xy plane. Okay. So it will be like this. So therefore, contribution to B dot dl from section 2 will be 0. Okay. Therefore, your net B dot dl from Q to P will be just because of section 1. So it will be mu naught I by P. Okay, so hope this is clear. Just taking you through the whole thing again. Okay, so Dhruv, hope this is clear.
Yes, sir.
Okay, now I'm
Sir, one more doubt. Like for section 2, it was 0 for QP. So would it be 0 for any other line lying in this plane?
तो के लिए क्या होगा ना, you take any section, any arbitrary curve lying on the xy plane.
Okay.
Take any curve like this on the xy plane. यहाँ पे अभी कोई भी point पे B कैसा होगा? Z axis के लॉन्ग होगा?
Yes, sir.
B dot dl क्या होगा? 0 होगा.
0, 0. Fine, sir.
Okay. So Dhruv, I will come back to some more of your questions. In the meantime, I will also now go to one of the questions from Prayush. Okay.
Okay, sir.
So there will be some questions. So let me turn by turn go through everybody's questions. Okay, so next we will see a question out of the list that Prayush has sent. So Prayush, the first question you have sent me, Prayush, you can unmute yourself.
Yes, sir.
Yeah, the plano-convex lens with radius of curvature r is lying on a reflecting plane surface such that the convex part of the lens is in contact with the plane surface. Lens is illuminated from above. The shape of interference fringes. It should be circular only. So this is not the correct answer you got.
No, sir, I got it correct, but I don't know. Sir, is it because the Newton's rings?
So I'll explain why it happens. Okay, so this is basically circular interference fringes. Yes, it is similar to Newton's rings. So this happens this way because when you keep a plano-convex lens like this on top of a plane mirror,
Yes, sir.
you're keeping it on top of a plane mirror. Now, a beam of light which is incident vertically, what will happen is it will undergo partial reflection over here at this surface and partial reflection at this surface and then partial reflection at this surface. Okay. So the optical path difference between the reflected light at the point E, reflected light at the point B and reflected light at the point C, it is a function of the thickness of the lens over here.
Yes, sir.
Okay, so वहाँ पे अगर उसका thickness suppose D है, so E और B के बीच जो optical part difference हो रहा है delta x optical, that is refractive index of the lens into 2 times D. Okay, similarly delta x optical between the light reflected at E and C will be like this. It will be 2 mu D plus 2 times this. If this total thickness was, let's say, T and this part is D, then it is plus 2 times T minus D. Okay, so it is like this. So the net phase difference that you're getting is a function of these. So that means it is a function of the thickness D. So you can see that that is in this diagram that D is repeated at this point and this point. Okay. So if you take a point which is at a distance Z on this side and another point which is at a distance Z on this side, the optical path difference is repeated for these 2 points. Getting the point now? So therefore what will happen in 3D, when you take all points which are at a distance Z from this axis, they are a ring. So therefore your phase difference delta phi is common for points at symmetric distance Z from the axis on the plane surface. So that is why that forms nothing but rings. Okay, so that is why the pattern of the interference that we will see will be rings. Okay, Prayush, so I hope this question is clear.
Yes, sir.
So you wanted to know the reason why it is circular, right?
Yes, sir.
Okay. Now next question also you have got it correct, but you have difficulty with the question, right?
No, sir, I just got it correct because I didn't know anything how to solve, but I multiplied 2 numbers.
Okay, so let's discuss. Okay, so 2 solid bodies. So let's come to the next question. So this is saying that there are 2 solid bodies which rotate about a stationary axis, stationary and mutually perpendicular axis with constant angular velocity. This and this. So omega 1 is equal to 2 radians per second, and omega 2 is equal to 4.5. radians per second. Okay. So this is, let us say, about the stationary x-axis, suppose, because it's saying mutually perpendicular axis, and this is about the stationary y-axis. Then we have to talk about the angular acceleration of one body with respect to the other. Okay. So here what happens is that you have to understand one thing, that whenever you have a rotating axis, okay, then any quantity which is, so basically it will become the product of these two. So I'll explain why it will become the product. Because if you have,
So why will there be angular acceleration only for one with respect to other?
that is what I'm trying to explain here.
Okay,
It's like this. Okay, so see, what happens is, now forget this case for a moment. Okay, so suppose we have a situation where we are looking at an xy plane. And in this xy plane, we have some arbitrary vector E. Okay, so A is, let us say, a stationary vector. With respect to xy plane. Okay. Now, suppose I next start making the xy plane itself rotate about the z axis with omega. Suppose the xy plane now rotates with respect to ground frame with an angular velocity of this omega k cap. Okay. So then what is happening, that your vector E, it was some ex I cap plus ey j cap, but here I cap and j cap are rotating with respect to ground. These are both rotating with respect to ground. Okay, so there is a d I cap by dt and there is a d j cap by dt. So accordingly, there is a dA by dt also. It starts changing with time. So how we calculate that is like this. Now notice that in ground frame, with respect to your z-axis, at some point of time, let us say your I cap is like this. This is at t equal to t. Now a very small time later, your I cap would have rotated and become like this. At t equal to t plus dt. Okay. So what is the change in I cap? It is this quantity. And this quantity is rotated by d theta. So it's nearly d theta because this is unity. Okay. So any unit vector would have changed by how much? D theta, in which direction? Perpendicular to itself. So di by dt would have become d theta by dt or omega into j cap. And similarly, if you look at this dj cap by dt, it would have become d theta by dt or omega into minus I cap. Okay. So it is like that thing in circular motion you studied, na, that if you have r cap, then dr cap by dt in circular motion, if this thing is rotating with omega, then at any point you have an r cap vector and a theta cap vector. So your dr cap by dt becomes how much? It becomes omega theta cap, and d theta cap by dt becomes minus omega r cap. Okay. And that is why ultimately your dv by dt, it becomes minus omega square r cap plus r alpha theta cap, like that. So anyway, without getting into all that, you can see that, so we have those relations that if omega is uniform, then V becomes omega cross R, and your acceleration, which is centripetal, becomes omega cross V. So you can see from here that dr by dt becomes omega cross R. dv by dt becomes omega cross V. So like that, any vector becomes omega cross of that vector. Understanding? So for example, if that vector was ax I cap plus ay j cap with respect to the rotating xy plane, then dA by dt will become, now it's a constant vector, so ax is remaining constant, but di by dt plus ay into dj by dt with respect to ground. Okay, because with respect to ground, I cap and j cap are rotating. So rate of change of this will become ax into omega minus plus j cap plus ay into omega minus I cap, like this. Okay. So you will see that dA by dt actually becomes omega cross E. You work it out, because omega in our diagram was about the z axis and E was ax I cap plus ay j cap. So this is one way to derive it. Or another way to derive it is that you can write your vector E in terms of radial and tangential component also, r cap and theta cap instead of I cap and j cap. But either way you will understand. So hope this relation is clear, Prayush. Okay. So now in this case, what is happening is that you have omega 1, which is omega 1 I cap, and omega 2, which is omega 2 j cap. Okay. And you have to calculate omega d omega 1 by dt in the frame of the second rotating body. Okay. So that will just become omega 1 cross or omega 2 cross omega 1. Understood? And in this case, they are I cap and j cap. So it will just become omega 1, omega 2 plus or minus k cap, whatever that is the case. Okay. So that will be your alpha 1 with respect to 2. So magnitude as well. So hope this is clear, Prayush. All right. So next time, also moving on to some more doubts. Yashraj, I'm moving on to your doubts. Kritika, you haven't sent me any doubts yet, I think. So you have sent me some doubts. Okay. So wait. Before Yashraj, I will come to Kritika's doubt. Okay. Yeah, Kritika, I've unmuted you. I've got this question from you. Consider an ideal gas. This one you wanted discussion of?
Yes, sir.
Yeah. Okay, so let's look at this example. It says that you have an ideal gas which is confined in an isolated closed chamber and the gas undergoes an adiabatic expansion. So ideal gas undergoes an adiabatic expansion. The average time of collision between molecules increases. Okay, so average time between collisions. That increases. So it is proportional to v to the power of q. Where q should be how much? In terms of gamma. So basically, we have to calculate this average time between collision. Let's say tau. So tau's relation with volume. Okay, this is what we have to calculate in this particular question. So let's understand how we'll calculate tau. So if you take an ideal gas, what is the relationship of average time between collisions with respect to any of the parameters? So we have a gas confined to this. Okay. Then the pressure acting on any wall, which is average force divided by area. Now average force is total number of molecules into average impulse. So if, for example, the wall we are talking about is the wall parallel to the YZ plane. So molecules which are coming and hitting it, each molecule will on an average apply an impulse of 2m Vx mean. And average time between two successive collisions is this. Okay. So the relationship between pressure and this is that pressure is proportional to Vx average divided by time between collisions. Okay. And Vx average, as you know, is Vrms by root 3. Okay. So P is proportional to Vrms by tau, which means that pressure is proportional to. Now Vrms itself we can express as square root of 3 PV divided by total mass. Okay. You can say this is proportional to square root PV divided by tau. So that means this is proportional to square root V by P, and your PV to the power gamma is constant. So that's how you get the relation between. So now replace pressure in terms of gamma, okay. And that's how you can replace the relationship between volume and time, average time of collisions. Okay, so hope that is clear, Kritika. Okay, so that was a doubt from Kritika. Now moving on to some doubts from Prayush. I have discussed, Yashraj. So a couple of doubts from Yashraj next. Just give me a moment. I have to open these questions and Okay, so let's come to this particular question. Okay, so it says that we have a long straight cylindrical shell which has inner radius r(i) and outer radius r0. So and this is carrying a uniform current distributed over its cross section. So it has a current I uniformly distributed over its cross section. So if you look at the cross section, it is like this: inner radius, outer radius, and it's carrying a current I, let's say, coming out of the plane, uniformly distributed. So you know from Ampere's law that if it is just this thing alone, what kind of magnetic field it creates? It creates circular magnetic field lines outside and zero magnetic field inside. Such a thing will create magnetic field lines which are circular like this outside, but zero inside. Okay. So that is the thing. Now it's saying that in addition to this, a solid wire of radius r is to be placed parallel to the axis cylinder, axis in the hollow region. So we are now also keeping a solid wire inside this now. Let's say this is a solid wire with a radius r. Now this is to be placed parallel to the axis of the cylinder. And r is less than r1, which is the inner radius of this one. So now we have to match various options. So first option is saying, so listen to the first option carefully everyone. It says that the magnetic field is zero everywhere in the hollow region. So then we can conclude that the wire is on the axis of the cylinder and carries current I in the same direction as the shell. So this option obviously becomes wrong. Okay, because this option is saying that if you place the axis of the wire and the cylinder coaxially, so let's see what will happen in this kind of case. So if I have, suppose this is my cylinder and that's my cylindrical shell, this is my hollow cylindrical, solid cylindrical wire. Now this solid cylinder, suppose we place it coaxially, and this is also carrying some current, that one is also carrying some current. So in this case what will happen is, suppose this is carrying a current coming out of the plane, this will create magnetic field lines here, and outside the magnetic field will be because of the hollow one plus this, so there will be magnetic field inside, okay, due to only the solid cylinder of radius r, and magnetic field outside will be the superposition of the field due to solid cylinder plus the magnetic field due to the cylindrical shell of radii R1 and R1. So outside, okay, there's a possibility is if this one is carrying current into the plane, this one is carrying current out of the plane, and the two currents cancel each other, it's possible that the outside field might become zero, but the inside field cannot become zero. So this quantity has to be non-zero. This quantity may or may not be zero. Okay. So that is what rules out option A. Okay, Yashraj, I'm unmuting you. This is your question. So hope you understood. Option A is not possible because of this. So it says magnetic field is zero everywhere in the hollow region. So from that we can conclude that that the wire is on the cylindrical axis and carries current I in the same direction. That becomes wrong. Yes, yes, Raj, is it?
Sir, but the current is in the same direction.
But वो inside the hollow region कह रहा है ना बेटा? कैसे
सर, आप जब वो वायर नहीं डाल रहे थे अंदर तब इनसाइड मैग्नेटिक फील्ड जीरो था ना, जब वो सॉलिड सिलिंड्रिकल वायर अंदर नहीं था.
हाँ.
सर वो जो जीरो होता है अंदर, सर वो क्यों होता है? क्योंकि सारे अंदर के कैंसिल हो जाते हैं ना मैग्नेटिक फील्ड. अगर हम देखें तो मतलब अगर मैं इस हॉलो सिलेंडर का एक एलिमेंट लूं.
Listen to the option, better listen to the option. It is saying that if the magnetic field is zero everywhere inside the hollow region, we can conclude that the wire is on the cylindrical axis and carries current I in the same direction. So it's saying that on the one hand, the cylindrical shell and the wire are carrying current in the same direction. And the second hand, you are saying that over here in all the hollow part, you're concluding magnetic field is zero. So how is that matching? In the inside region, the magnetic field due to the shell is zero, but the magnetic field due to the wire is non-zero, na? So how can the net magnetic field be zero?
हाँ ठीक है.
You understanding the point? अगर देखो ये वाले पॉइंट पे जहाँ मैंने डॉटेड वाला कर्व बनाया वहाँ पे अगर मैग्नेटिक फील्ड जीरो है, then B dot dl should be zero, integrated.
Yes.
So if B dot dl is zero, how can there be a current contained inside? You understanding the point?
Yes sir.
तो अगर मैग्नेटिक फील्ड यहाँ पे जीरो नहीं है, okay, there is if the magnetic field is zero, that is what the question is saying. Magnetic field is zero everywhere inside the hollow region. The conclusion is that there is no wire here. There is only the shell.
Yes sir.
You understanding the point now? So वो उल्टा हो गया ना? It's opposite of what option A is saying.
Yes sir.
Okay, so option A is ruled out. Okay. Now let's come to option B. It says that the magnetic field is zero everywhere outside the shell. So now this thing is happening. What we have said that it may be zero, no? So this can be zero, but वो किस केस में हो सकता है? When this current and this current are in the opposite direction. Got it now? यहाँ पे magnetic field अगर zero है, then when we draw an Amperian loop like this, the net current enclosed has to be zero, no? So the current, so the second option is saying that the magnetic field in the outside region is zero. That can only be possible in this case where the magnetic field in this region, let's say, is going into the plane. Sorry, the current in this region is going into the plane. The current in this region is coming out of the plane, and they are equal and opposite. So B0 means that the net current enclosed is zero. So that is only possible. So now let's check what option B is saying. So we conclude that the wire is on the cylindrical axis and current carries current I in the direction opposite to the direction of the shell. So option D becomes correct. This means that the current in the wire is exactly negative of the current in the shell. They are equal in magnitude but carrying current in opposite direction. So option B becomes correct. Okay, similarly, let us look at option C. The magnetic field is zero everywhere in the hollow region. We conclude that the wire may be anywhere in the hollow region but must be carrying a current. No, so that is wrong. Okay, because again, the only way the magnetic field in this region is zero is if there is no cylindrical wire anywhere inside. Now, the entire region inside the shell should be completely hollow. There should be no current carrying wire. So that is why option C also becomes wrong. And option D is saying the magnetic field is zero everywhere in the hollow region. We conclude the wire does not carry any current. That is the correct option again. So B and D should be the correct options. that was question number 6. All right. So next question you have asked, Yashraj. I'm coming to that. Question number 8 from this paper. So this question is now saying that a mirror is hanging by a light string of length L from the ceiling. A light pulse of monochromatic light rays is incident normally on the mirror and gets reflected. Okay. So this has to do with basically the concept of radiation pressure. You have light thread and you have some kind of a mirror which is hanging like this. Now you make some kind of monochromatic light or light beam, basically, not necessarily monochromatic, incident on this. So what will happen is, because of reflection, there will be a force acting on the mirror. So you have to think about the force due to radiation pressure on the mirror. What kind of force it is? You will realize it's a constant force. Okay. So how we calculate this force is that if on the surface of a mirror, okay, if a single photon is reflected, okay, so reflection of a single photon, it results in impulse equal to 2 times h by lambda, because it reverses with the same wavelength always. Okay. So the force becomes this impulse into number of photons incident per unit time. So it becomes 2h by lambda multiplied by number of photons incident per unit time. So that is intensity of the beam multiplied by the area. Okay, that is energy incident per unit time divided by hc by lambda. That is energy of each photon. Okay. So dn by dt, that is number of photons incident per unit time on the mirror. So this thing can be calculated as energy incident per second divided by energy of each photon. So energy incident per unit time is intensity into area. Okay, so here I is intensity in watt per meter square. E is area in meter square, and energy of the photon will be in joules. So you are getting this in per second. Okay. So now coming back to this calculation, the force becomes independent of lambda, as you can see. It becomes this. So the force is directly proportional to the intensity and area, but it is independent of lambda. And that force will decide how much it gets the angular amplitude to which it goes, to because now there's a continuous force like this acting on it. So, it will be at an equilibrium position where F and mg are vectorially balancing each other tangentially. But by the time it reaches equilibrium, it will have kinetic energy. So it will go past equilibrium. So it is like that angular oscillation where there's a continuous amount of force acting from one side. Okay, and the amplitude will be directly proportional to that amount of force. Okay. So hope this question is also clear, Yashraj. Okay, good. So now I will come back to some more questions. So Dhruv, I'll come back to your set because there were quite a few questions in that. Okay, so next question from Dhruv I will put up for all of you. So here what is happening is there are two sources of sound which are equidistant from a receiver here. So S1 and S2 are coherent sources of sound. Equidistant from the point P. Okay, next what we are doing is speed of sound in normal air is 340 meters per second. Now what we're doing is, in between, we have created a section which has hot air, and the width of this section is d. Has temperature equal to 4 times temperature of normal air. Now since nothing is given, I'll have to assume that this 4 times is in Kelvin. Okay, because if it was in centigrade, it's something else altogether. Okay, so you'll have to assume that this temperature is 4 times, that is in the absolute scale. And the width B is given to us as 85 meters. Okay, so we have to find out the minimum frequency of sound so that there is destructive interference. So find the minimum frequency of sound that is from source S1 and S2. They are same frequency because they are coherent, so that minimum intensity is heard, or in other words, there is destructive interference. At P. Okay. So just try out this question, all of you. I'll give you a hint. What is happening in this question is, it is something like, in case of YDSC, Young's double slit experiment, when we place some kind of a slab where the speed of light becomes less, so it creates an optical path difference. So the equivalent of that is happening over here. Even though the path length S1P is equal to the path length S2P, but because here is going through a hot air pocket, but still there will be phase difference. Still phase difference is created because S1P takes shorter time. Okay, because speed of sound becomes larger than speed becomes greater in the hot air pocket. So that time difference, whatever the delta t, it creates a phase difference. So that is a hint in this question. Use a similar type of concept that you use for optical part difference when you place a slab. Just try this question out, all of you. Okay, so hope you worked this out, people. Now see, one of the easy ways to do this is to relate it with that optical path concept. So you can see that inside this, in the hot air, the speed of sound, let's say it becomes this, it becomes 2 times the speed of sound in normal air, because the temperature, V, is proportional to this kind of thing. So molecular mass of sound is not changing, of air is not changing. So temperature is becoming 4 times, so speed of sound there is becoming 2 times. So you can say that this length d, it becomes equal to an effective length of half, because speed of sound is double. So sound traveling through d distance at temperature equal to 4 times normal temperature, it is equivalent to d by 2 at temperature equal to T, because it's traveling at double the speed. So therefore, the path difference, the equivalent path difference becomes d by 2 between S1P and S2P. So phase difference becomes 2 pi by lambda into d by 2. This is one way of doing the question. Okay. Or another way of doing the same thing is that the time difference created, okay, between path S1P and S2P is equal to d divided by V prime minus d divided by V, where V prime is basically equal to twice of V, because the temperature is 4 times the normal temperature. Okay. So that way you can say that the time difference will have a magnitude of d by 2V. Okay. So phase difference delta phi is omega into delta t. So 2 pi frequency into d by 2v. I'll see that this thing and this thing are one and the same thing. And the equation we have written earlier, this and this are the same, because v is equal to f lambda. So whether you express it in terms of time difference or in terms of path difference, it's one and the same thing. Okay. So 2 pi by lambda into d by 2 is the same thing as 2 pi f by v into d by 2, because v is equal to f lambda. Okay. So 1 by lambda is same thing as f by d. So anyway, now this thing should be equal to 2n plus 1 pi for destructive interference. Okay. So just relate it with this. So the frequency should be equal to 2n plus 1 into v by d. This 2 cancels, pi cancels for destructive interference. So minimum frequency should be equal to v by d. So now just relate it with the data in the question. So the question, d was 85 meters and speed was 340. Okay, so hope this is clear. Dhruv. Coming to another question sent by Dhruv. Yes, Dhruv, you can unmute yourself. Yes, Dhruv, you can. Yeah, tell me.
I got this question. I also had a doubt, when we consider that interference due to a thin slab.
Yeah.
In that case, if we consider the interference between the transmitted transmitted light.
Hmm.
So in that case, which two transmitted lines do we consider?
Interference due to thin slab.
Yes, sir. Like one, though we know that due to reflected light there is interference.
Yes. No, so
But
if there's a slab like this, okay, and it's
yes,
kept
sir.
surface like this, like a thin film kind
Sir,
of.
no, I am not keeping any surface. You can consider three different mediums.
Okay. So in that case, what is happening is, see, if you just have a thin film like this,
Yes, sir.
it is incident somewhere like this. Now, what will happen is part of the light transmits, part of the light reflects.
Reflex, yes, sir.
Then again, here part of the light transmits, part of the light reflects.
Okay.
Then this happens. Then again, here also there is part reflection, part transmission.
Fine.
So actually, there's a
Acha.
ये होता रहता है. Even though
Okay.
what is happening is that the intensity of this will be greater than this. So these beams, the intensity goes on decreasing. Similarly, these beams, the intensity goes on decreasing.
Okay, sir.
Okay, so that's how the interference happens.
Yes, sir. Thank you.
Yeah. So next time coming to this magnetic field based question that you have said. So this question is clear. So I'm now moving on to the next one. So in the next question, what is happening is that we have a cylindrical region in which there is some magnetic field like this. In this cylindrical region, there is magnetic field going into the plane. Okay. And this magnetic field going into the plane has a magnitude of some constant into time plus another constant, where C1 and C2 are both positive constants. Okay. And we have a triangular metallic frame, which is something like this, let's say. So we have this triangular metallic frame in the shape of equilateral triangle of side length L equal to 2r, where r is the radius of this region. This magnetic field exists. This is magnetic field in cylindrical region, which is of radius r. So this radius here is r, and this magnetic field is B going into the plane. Okay, so now what we have to do here is we have to find, okay, now this metallic thing also has a resistance per unit length of something given to us. Resistance per unit length of lambda. Okay. So find the potential difference VA minus VB. You have to find this. Okay. So this is again a direct type of question. So what we'll have to do is we'll have to calculate the induced EMF across the loop by using this thing. Now the point C is the center of the loop. Point C is the center of the cylindrical region. So you have to use that also. And from that you have to find the rate of change of flux through the triangular loop. And from that you have to find the induced EMF. Now that induced EMF will be equal to current into resistance. And across the wire AB you will see there will be no induced EMF because there is no overlap with the magnetic field. So the potential drop will just be IR, where R is the resistance. So what you have to do is you have to find E induced first. From that you have to find I, which is E induced divided by total resistance. Okay, and then VA minus VB will be just I into resistance across AB, which will be total resistance is 1/3. So it will be basically 1/3 of induced EMF. Okay, just work this out. So hint to you is that you can see that a certain sector of the circular part, circular cross-sectional area is within the triangular loop. So area of that sector into magnetic field becomes flux. So rate of change of flux is very easy to calculate. Just wait, this will not be completely correct. We'll discuss. There will be some induced EMF in this also. So you have to understand that. No, VA minus VB will not be 0. So you have to understand few things. First of all, you have to understand that there is non-conservative electric field. In this situation, there is non-conservative circular electric field lines, which are such that B going into the plane is increasing. So they will be coming out of the plane, so they will be anti-clockwise. Okay. So there will be electric field lines which are like this in this region. Okay. And outside also. There will be these kind of electric field lines. So there will be non-conservative circular anti-clockwise electric field lines. Okay, both inside and outside the cylindrical region. and you even know how to calculate the magnitude of the field using Ampere's law. Okay. But we won't get into that here. We won't be making use of that. But now if you look at the overlap of those field lines with this thing, with the circular loop, with the triangular loop, you'll understand something interesting here. So what is happening is that the triangular loop's center coincides with the center of the circular field lines. So that is why यहाँ पे for example electric field का direction कैसा है, ऐसा है, perpendicular. यहाँ पे electric field का direction कैसा है, ऐसा है, is perpendicular. The electric field lines cutting across like this. Again, you can see here the electric field is perpendicular. Here the electric field is perpendicular. So there is no potential difference because of that electric field which is created across this section of the wire. Okay. Across the section BC and CA. Okay. So E dot ds across BC and E dot ds across CA are 0. Okay. So there is no induced EMF across BC and CA. So E induced in part BC and CA is 0. That means E induced across part AB is equal to E induced for the loop ABC. This is one important thing you have to understand. Okay. Now for the loop ABCA, you can also calculate induced EMF without doing that E dot ds at all, by just considering the fact that the overlap of the magnetic field, something like this. So to just consider now, this. So if this section's area is A prime, then the magnetic flux through the loop is that area into B. So that area will be, because it is subtending 60 degrees at the center. So it will be 1/6 of pi r square into B. So magnetic flux through loop ABCA will be pi r square by 6 into C1T plus C2. So, and the sense is into the plane. So induced EMF in loop ABCA will be minus of pi r square by 6 C1 into the plane. So minus means it will become anti-clockwise. So E induced for the loop ABCA will have a magnitude of pi r square C1 by 6 anti-clockwise. Now put together this with the information that you know earlier, that EAC will be equal to ECB, which will be 0. So EAB will be E for the loop ABC. So now convert the loop into a circuit, and you will understand that that circuit will look something like this. Okay, so these three resistances are equal. Lambda L each, or 2 times lambda R each. Okay. So now this potential difference VA minus VB will be minus E plus I. So it will be minus of pi r square C1 by 6 plus I into 2 lambda. This where I is equal to E divided by net resistance. So that is pi r square by 6 C1 divided by 6 lambda. So it is basically equal to, so therefore you can see that VA minus VB will be equal to minus E plus E by 3. It will be minus 2E by 3. So it will be minus of 2/3 of pi r square by 6 C1. So this is the answer you should be getting with the proper algebraic sign and all, according to me. Okay. So I'll just take you through all the concepts over here. Starting with this section. Non-conservative electric field lines are created. Yeah, yes, sir, you got the idea correct. Yeah, Yashraj, to answer your question, non-conservative field lines are being produced by time-varying magnetic field. That is the effect of time-varying magnetic field. No? Electromagnetic induction में दो type of situation होते हैं ना, motion generated EMF. When your magnetic field is constant, but there is a conductor moving inside it, then there is polarization of charge, and there is motion generated EMF, which is because of a conservative field, because of polarization of charge. But on the other hand, when there is a time-varying magnetic field, it creates that non-conservative, non-electrostatic type of field. There is no polarization of charge. This field is not created by static charge, so it is a non-electrostatic field. It is a non-conservative, non-electrostatic field created by time-varying magnetic field. So that is a very key thing in this question, okay? Because the magnetic field is in a cylindrical region, so your magnetic field lines are circular in, sorry, your electric field lines are circular in shape. Now, because your electric field lines are circular in shape, okay, there are circular electric field lines. That is why this thing is happening. That this E dot ds or E dot dl whatever in this part is 0, because ds is like this and E is like this, so they are perpendicular. Same here. So this is a very key thing over here. Yes, I will come to it. Yes, sir. Okay, so next question, Yashraj, I'll come to your question, but before that, there is one question from Prayush I want to discuss. Yes, Dhruv, I will share the PDF for this session. So the final part is the circuit diagram. Just go through it once, then we'll come to the next question. Okay, so the next question is from Prayush, and that is something like this, that we have a hemispherical bowl kind of thing. Just a second. Just give me a minute, I'll reshare that. Yeah, so we have this hemispherical bowl kind of thing, which has a uniform distribution of charge. So it has uniform sigma. And then what we've done is, at the center of curvature of this, there is a small electric dipole that is placed like this. So C is the center of curvature. At that, we have placed a small electric dipole of dipole moment P like this. So we have to find the time period of small oscillation. Find time period of small oscillation, okay, of the electric dipole. Okay. So the main thing is, because of this shell, if I find the electric field at that point, okay, I know that if the electric field due to the hemispherical shell is known, then that electric field is like this, and in that I have placed the electric dipole parallel to it like this. Okay. So when I take the dipole to an angular position theta, it will create a torque P cross E, which is restorative. So it will create a torque which is minus PE sine theta, the opposite to theta. Okay. So it will create I alpha, or I into d2 theta by dt square, which is equal to minus PE sine theta. So for small theta, we can approximate it as PE theta. So d2 theta by dt square will become minus PE divided by moment of inertia into theta. Okay. So time period of oscillation will become 2 pi under root moment of inertia by PE. So for all this, now I have to calculate moment of inertia and I have to calculate the electric field. These two things need to be calculated. So let's start by calculating the electric field due to the hemisphere, which is like this. Okay. Hemisphere is sigma and radius r. So start by finding electric field at the center of curvature C of the hemisphere. Okay, though. And the moment of inertia of the dipole is also given as I. So moment of inertia I, that is also given. So we only have to calculate this. So कैसे निकालेंगे? You can integrate for rings. So for this hemisphere kind of thing, I want to calculate the electric field at the center of curvature. So slice a ring like this. at an angular position theta, slice the ring like this. So the center of the ring is, let's say, this point P. So the thickness of the ring is RD theta. The radius of the ring is small r, let's say. Okay. So x, which is basically the distance PC, is capital R cos theta, and radius of the ring is capital R sin theta. So the area of the ring is 2 pi r into thickness. So that becomes 2 pi r square sin theta d theta. So the charge on the ring becomes sigma into dA. Now that ring is creating an electric field like this over here, which will come from the formula of electric field due to the ring. Okay. It will be 1 by 4 pi epsilon naught dq into x upon r square plus x square to the power 3 by 2. So here you can see r square plus x square is nothing but capital R square. Okay. So this becomes k into sigma into dA, which is 2 pi r square sin theta d theta. That's your dq into x, which is r cos theta, divided by r cube. That is it. So electric field is integration of d for the hemisphere. So that is sigma k into 2 pi bar आ गया, r cube cancel हो गया, cos theta sin theta d theta integrated from theta equal to 0 to theta equal to pi by 2 because it's a hemisphere. So you can put sin theta as z, and so this will become sigma into 2 pi by k will become basically sigma by 2 epsilon naught. Okay. And this will become sin square theta by 2 from theta equal to 0 to theta equal to pi by 2. So this will come out to be sigma by 2 epsilon naught. Okay. So interestingly, this is the same as the field due to an infinite sheet. So your time period, which was 2 pi under root I upon PE, will become substitute this. Okay. So I'm just minimizing this to go through. So this is electric field at the center of curvature of a hemispherical shell having uniform sigma on its surface. That was the main point of the question. Dipole thing was direct formula based. it should be sigma by 4 epsilon naught. Yeah, sorry, this is half. So this is sigma by 2 epsilon naught into 1 by 2. So it is sigma by 4 epsilon naught. Just make a correction here. Okay, good. Now, next question by Prayush was that ideal gas of molar mass. So we have an ideal gas which has molar mass m, is kept in a tall cylindrical vessel of base area E and height h. So volume is AH and temperature T, and the pressure at the bottom is P naught. Now the important thing is here they are talking about a tall vessel of height h. So we'll have to assume that there is some kind of a pressure gradient. Tall means extremely tall, something like that, like tall in several kilometers and all that. So we have to assume that there is a pressure gradient. We have to assume that there is, this is your y-axis, there is del p by del y equal to rho g. So the pressure here is P. The pressure below is, so dP is equal to minus rho g dy. That's one equation. And Pm is equal to rho RT. Now temperature is uniform. Okay. So this is your second relation. So now if you relate this and this, you will see that dP is equal to RT by M into d rho. This is the relation. Okay. Or from here, rho is equal to Pm upon RT. Okay. Where P is now pressure at the bottom minus you have to use integration basically because pressure is varying now. So density is also varying. So if the pressure at the bottom is P naught, then at a height y above, the pressure P will be such that minus or dP was minus rho g dy. So dP was minus Pm by RT times g dy. Okay. So dP by P is equal to minus mg by RT times dy. So when you integrate this, at y equal to 0, the pressure is P naught. And at y equal to y, the pressure becomes P. The pressure as a function of height, y, will become P naught e raised power minus mgy by RT. So the pressure is like this, then the density is Pm by RT. So it is P naught m by RT e raised power minus alpha y, let's say, where alpha is the constant mg by RT. So then your total mass of the gas will become integration of rho dV, that is rho A dy. So it will become where alpha is mg by RT from y equal to 0 to y equal to h. Okay, so this is the total mass of gas in the container. So Prayush, I hope the method is clear in this. You can complete the integration yourself. So the trick was interpreting the question correctly in saying that because it was a tall vessel, so density is non-uniform. And pressure is also non-uniform. Okay. Okay, so people, unfortunately, I have to conclude the session here today. I have an important parcel to pick up, which has to be done by 11. Okay. So rest of the questions that you people have sent me, I will send you some hints. Okay. And request you to be on time from next time because we started around 8:30 today. Anyway, so we will have a doubt session very soon again. But in between also, you don't need to wait for the doubt session. You can keep sending me your doubts on WhatsApp, and I will keep sending you some hints or formula or whatever is required. Okay, and I'll send you the recording and the this thing and the PDF for this one. And I'll try to send you some hints or some kind of solution for all the questions that you sent me today by WhatsApp. So don't worry about that part at least. Okay. So that's it. Thank you for attending, guys, and wish you all the best and stay safe during the lockdown.